Hello, my name is Enrico, and I'm with Ocean Research College Academy, and I'll be talking about temperature and pH trends in Possession Sound from 2016 to 2022. And this research was funded by the National Science Foundation Geopaths Grant. So ocean acidification is the lowering of the ocean's pH due to increased concentrations of atmospheric carbon dioxide. And this is a global issue that affects many bodies of water, leading to biodiversity loss, changing weather patterns, or other consequences. Anthropogenic influences such as deforestation, fossil fuel burning, or others increase the amount of atmospheric CO2. And due to this, the ability of the marine environment's buffering capability cannot adapt and function at a high enough level to combat the changing pH. pH, by definition, is the measurement of the acidity or alkalinity of a solution based off the concentration of hydronium ions present. It is a logarithmic scale, and at standard temperature, a neutral solution has a pH of 7. Solutions with a pH higher than 7 are basic, and solutions with a pH lower than 7 are acidic. So atmospheric carbon dioxide is absorbed by the ocean, leading to it dissociating into carbonate ions and hydronium ions. And this lowers the pH of the ocean, also known as turning the water more acidic. Trends of ocean acidification also show an increased water temperature. And additionally, this increased water temperature creates a positive feedback loop for ocean acidification because this increased temperature causes an increased reaction rate of the dissociation of carbon dioxide. This suggests that the temperature change is a dominant factor in the changing pH variation during seasons. So my goal of my study is to take these suggested ocean acidification trends of an increase of temperature and a decrease of pH, and to see if those trends are in our local possession sound environment to assess ocean acidification here. So the field set that I'm looking at is Mount Baker Terminal, or MBT, and this site was chosen due to its proximity to urbanization, being able to have clear influences of anthropogenic changes. So all the data was collected by Ocean Research College Academy, or ORCA, and it was done on state of possession sound cruises, or SOPS cruises. The specific SOPS cruises were SOPS cruises 111 to 203, and these were over September 14, 2016 through January 21st, 2022. And all the pH, temperature, and depth data was collected by YSI Exosonde. So my first figure is a compiled pH focused graph, and this is in comparison to depth. It is a good visual of all the casts that I focused on during this time period. And overall, pH trends tend to be a little more acidic around the wintertime, as seen on these blue arrows here. And pH is a bit more basic in the spring and summer seasons, as seen in these green arrows here. And just want to note that outliers above 8.5 and below 6.5 were emitted, and most likely due to sensor error. My next figures here are scatter plots divided by years 2018, 2021, and it shows pH profiles at depth with temperature as a color gradient. And overall, temperature trends per profile are fairly normal, with temperature generally decreasing as depth increases. And here's an example of that in the lower left with the red arrow. And regarding pH, data seems to be very varied throughout each year, and this is most likely due to seasonal differences. Outliers over 8.5 and below 6.5 were emitted for these as well. So overall, there was no large change between the years, but this does not just discount the effects of ocean acidification on our local estuary, but this rather prompts an analysis of a longer time period for better trend identification and confidence. Additionally, seasonal framework would be better for a comparison between pH and temperature, and this would also help with more trend identification and confidence. And that is all for my presentation. Thank you so much for watching.